Okay. All right. So we were talking about the third chapter, that is coordinate geometry. And today we will talk about the equation of a circle. And you guys will get to find a lot of past paper questions coming from this subtopic directly, right? Coming from the equation of circle part. So this is extremely important. So please stay attentive. It's very, very important. Okay. This is basically the fourth section. The equation of a circle. So again, the format is going to be that we'll talk about some important key points, one basic example, and then we'll directly do the past paper questions as practice questions. Okay. All right. So this is the idea. Now, let's talk about a circle first of all. Now imagine, let me make the axis first. This is the y-axis. And let's say this is the x-axis. And here I have a circle. Okay. Now, this is the center of the circle. Let's say this coordinate is right here is A, and this one is B, and then this is the radius of the circle R. Okay. So always remember, when we talk about straight lines, we talk about its slope and we talk about its intercept. And then when we're talking about a straight line, in the point slope form, we're talking about a point on the line and its slope. Okay. So for every shape, things are different, but you guys get the idea from the equation of a straight line that we do have some key things about that very shape, which we need to use for making the equation of a circle or equation of that very thing. So for now, we're just talking about circles, and for circles, if you're interested in finding out the equation of a circle, or if you have an equation of a circle, just know that that is going to give you information about the center of the circle and the radius of the circle. Okay, so the two important things about equation of a circle are center of the circle and the radius of the circle. Why exactly am I saying so? You'll get to see that shortly. So if I talk about the equation of this circle, this is basically going to be x minus a whole squared plus y minus b whole squared equals r squared. Okay. Now clearly you can see that this is the x coordinate of the center. This was the center, and this is certainly the x coordinate of the center. This b is the y coordinate of the center. And then this r right here is basically the radius of the circle. Okay. So when we talk about the general form of the equation of a circle, this should come to your mind. It could be any scenario, anything. We'll talk about a basic example, but this is how it is. Okay. Now, obviously, the difficulty level of questions would be good here because this is the general form, but the examiner can give you an equation that would be for circles, but it won't be in this form. So first of all, you'll do some extra steps. You'll make that equation look like this one. And then the question would be about finding out the center or the radius of the circle and stuff like that. Okay. For now, just know this is how we write down the equation of a circle. And here comes the x coordinate of the center. Here comes the y coordinate of the center. And this is the radius. Okay. Let me do one quick basic example just so we get the idea clearly, and then we'll talk about past paper questions directly. Okay. Example number 1, it just says that find the equation of the circle with center -4, 3 and radius 6. Now you won't get to find a question of this type in past paper exams because this is very, very basic. Like you can, but you know, it's very unlikely because it's very easy. The purpose behind doing this example is just so you get comfortable with the equation of circle. Okay, now we know that the general form of the equation of circle is x minus a whole squared plus y minus b whole squared equals r squared, where a and b are basically the coordinates of the center. So this time around, I have -4 and 3 as center. So x minus, then I have a, and for my scenario, a is -4. So I'll write down -4 and then it's whole squared plus y minus b is basically the y coordinate of the center. Here it is. Whole squared equals radius squared. So radius is 6. So I can write down 6 squared and this would become x plus 4 squared plus y minus 3 squared equals 36. So this is going to be the equation of the circle with radius -4 and 3, with center -4 and 3 and radius 6. Okay, this is how we do such stuff. Okay, all right.
Miss,
Yes.
Miss, Miss, how did you reach the formula x minus a plus y minus b squared? Miss, from like the above example where you drew the circle.
Okay,
Like,
okay. Like this one.
yes, Miss. So like,
It's basically the Pythagoras theorem. Like it's basically coming from the Pythagoras theorem.
yes, Miss. But how are we like managing? How are you adding and subtracting the coordinates?
Okay, let me explain that over here. That's a good question. 1 second. I'll just make it over here. So let me make 3 points. Okay, are you familiar with the Pythagoras theorem? Right?
Yes, yes,
Okay.
Miss.
Okay, perfect. Let me just make the thing here. So this again is going to be the radius, because we know that any line that's going from center to circumference is the radius. This is my radius, and now I am going to make a right angle triangle. This is the right angle triangle. So this point is the center point, and then you can just have C, and then let's say P, this is P, and this one is Q. Okay. Why am I making the right angle triangle? Because of a reason. You'll get to know that reason. Okay. Now I know that since since CPQ is a right angle triangle, so I can apply the Pythagoras theorem, and through the Pythagoras theorem, I can say that CQ squared plus PQ squared is going to be equal to R squared. If you look at the red triangle only, you know that when you will sum the two smaller sides, and like when you square and then sum the two smaller sides, that would be equal to the square of the hypotenuse or the longest side of the triangle. Okay. Now, the next thing
Yes.
is that, yes.
No, Miss. No.
Okay. All right. The next thing is that now we need to make the equation using x and y. Okay. So for that, since center is defined, right? Center is defined. For the P and Q points. P could be like, I could have made this right angle triangle anywhere else, right? This center is defined, but for P, I could have made it on the other side as well. So for P, we use the coordinates as X, Y. Okay. And now if we start making it, like now if we start plugging in the values of P, Q and CQ, this would help you find out the equation directly. Okay, so if that is XY, this point right here, again, it has B as its Y coordinate and the X coordinate is going to be X, okay? Because this is point Q and Q is basically coming from the same Y coordinate, that's why it's B. And since for P, I said that the X and Y coordinates are going to be X and Y because it could be anywhere on the circumference. So Q is basically coming from the same thing. Do you get the idea behind the coordinates of Q?
Just wait a second.
Sorry, say it again.
Just can you give me 1 second?
Yes. Take your time. This is Q, okay? This is Q, and this is C. What is the, just forget everything, just look at this, okay? If I am to find out the Y coordinate of Q, that is B, okay? And if I am to find the X coordinate of Q, I'll just go down like this. And since I mentioned that the X coordinate of P is going to be X, so this line is a straight line. It's a vertical line. So whatever X coordinate would be for P, that would be for Q as well. Okay. So this is X. Okay. Very good. Well done. And this is going to be Y. Now, what exactly is going to be CQ? This is CQ. This length is CQ. So I can do X minus A, right? So I will do X minus A for CQ. And for PQ, this length exactly right here is basically the length of PQ. So that would be Y minus B. It would be Y minus B whole squared equals R squared. This is basically the derivation of the equation of circle, right? This is how we derive it. And why exactly did we keep this XY? Because I could have used any other variables for the center, like it could have been, let's say, H and K. We usually use H and K in some books. And I could have made the right angle triangle somewhere here as well. So the idea was supposed to be same, right? The idea is going to be same. You can make this right angle triangle anywhere, but obviously the hypotenuse side has to be the radius and every other thing would be sorted accordingly. And every time when you will derive it by yourself as well, you would get something of similar type. So this is basically the derivation of the equation of the circle. Okay.
Okay, miss. Thank you.
Okay. All right. Perfect. So any other thing, Munja and Motasam? If you guys were not able to understand it, it's okay. It's good that we talk about derivations as well, but it was just for Rafe. For now, we just know that this is the general form, and from this general form, this is basically the X coordinate of the center, and then this one is the Y coordinate of the center. And this is basically the radius. Okay. And then we did a basic example where we wanted to just discuss that where exactly the center and radius is going to be used, okay, in the equation. Okay. Now, any other question, Motasam and Rafe?
No, miss.
No, miss.
Okay. Munja, what about you?
Ma'am, thank you for the explanation. It makes sense. Thank you so much.
Okay. All right. Okay. Perfect. So now we can talk about the past paper questions directly. Okay. Just take 1 minute to, not 1 minute, take a few seconds to just look into it and just keep this in your mind. And then I am going to shift to the past paper PDF. Okay. I'll stop the recording at this point.